Okay, so this is lesson 2, starts on page 8, solve problems with percents. So you really needed to know or do lesson 1 before this, because you need to know how to relate the percent, the decimal, and the fraction, or convert all of them amongst each other in order to figure out solving problems with percents. And the reason why we solve problems with percent is kind of with our consumer math. So when you're going to a store and something is like 5% off, you know how to kind of figure that out in your head and figure out what the total price would be. And so that's kind of what we're trying to figure out here. So percents can be used to solve word problems, for example, or real world problems. For example, the sales tax rate is 5%. You would need to find 5% of the price of an item to find the amount of sales tax on that item. To find a percent of a number, you convert the percent into a decimal, then multiply that number by the decimal. So I don't know if you know about sales tax. But what it is when you buy, and our sales tax in Chicago is not 5%, it's much higher. But basically when you buy any kind of thing, whether it is like a food item or a toy or a piece of clothing, there is something called a sales tax. So it's a percentage of whatever you're paying, and that sales tax then goes to different things in the city or the state or the country to help pay for things that taxes pay for. So a tax is obviously something that's added on to what you're buying or spending or doing that help pay for certain city, state, and federal services. So for example, my job, public school teacher, I get my paycheck through taxes. I believe my paycheck comes from property taxes. So when your parents buy a house or buy some sort of property, they pay taxes on that property every year. And those taxes then help pay for teachers and our fire and policemen and women. It pays for the streets to be paved. It pays for parks. It pays for all sort of politicians and government services that we do. So taxes are something that are added on to what we pay for. So you need to know, so like when you're going into a store and you're buying a drink and the drink is labeled $1, you know you're going to pay more than $1 because of taxes, but it's a percentage of what you pay. It's not like a flat rate or a flat fee. It's a percent of what you're paying for. So obviously if you buy something that's more expensive, the tax is going to be more because it's a percentage of that. So when we find a percent of something, we take that percent, we turn into a decimal, and then we multiply whatever we're buying by that decimal to find the percent of that. Another common percent problem involves interest. To calculate the amount of simple interest, or I, you see it's a cute little slanted I, for an investment or loan, use this formula. I equals P times R times T. That means P is the principal, R is the rate expressed as a decimal, and T is the time of years of the investment. So what that means is, so if you were to buy something like a car, you may not use cash to buy that car. You may finance that car or get a loan to pay for that car. So the principal is how much the car cost. The rate is the percentage that you're paying more for. So like what banks will do, let's say your car costs $10,000, right? And you're like, I don't have $10,000, but I need this car. So you can ask the bank or to give you a loan of $10,000. And they're like, absolutely, we would love to help you out. Here's $10,000 to go buy that car. But the way banks make their money is by charging you interest or charging you a percentage of how much you borrowed for borrowing that money. So the principal would be like the original amount of the car, okay? And then the rate is the percentage that they're charging you. So, and a lot of times it's written as a decimal or a percent. So let's say the rate is, they're going to charge you 0.05 or 5% of this for borrowing that money. And then the time is how much it's going to take you, how many years it's going to take you to pay that off. So you're going to end up, like, if you pay it off in 1 year, you're going to pay less on your interest because you're paying it off quickly. If you're going to pay it off in 5 years, you're going to end up paying a little bit more. But your payments will be smaller over those years, but overall you're going to pay more. Your interest is going to be more. So this is the time that it's going to take you, okay? So to find the percent increase or percent decrease, write the difference in the amounts as the numerator of the fraction and write the original amount as the denominator of the fraction. So the percent increase or decrease, this is the amount of increase or decrease, and this is the original amount. Then divide, multiply the results, divide this, and then multiply the result by 100 and write as a percent to convert the decimal to a percent. So let's take a look at the example to see how that works. From last year to this year, the population of geese in a pond decreased from 200 to 150. What is the percent decrease in the goose population during that period? So you find the amount of decrease, it's 50, right? There's 50 less geese in the pond this year. So the amount of decrease is 50 over the original amount that was there a year ago. So 50 divided by 200, 50 divided by 200 equals 0.25, and that is a 25% decrease, right? And we know how to do that already. So from 1 year to the next, the geese decreased by 25%. The goose population decreased by 25% from last year to this year. Second example, Charlie's meal at a restaurant cost $11. He left a 15% tip. How much did the meal cost in all? So you're going to find the amount of the tip. You have to find like the dollar amount of the tip. So what is 15% of $11? So you're going to convert the 15% into a decimal, which is 0.15. And then you're going to multiply 0.15 of or times 11, because you're finding 15% of 11, and that's $1.65. Now, the meal did not cost him $1.65. That's how much he's leaving for a tip. So you take what the meal cost and you add it to the tip. So $11 plus $1.65. So his total meal was $12.65. So there's a pretty easy way, like tipping is kind of a common practice here in the United States. And a common tip is 15% of your meal. Lots of people like to tip 20% because it's nice, right? It's generous, but it's also there's a really easy way of finding 20% of anything. And the reason why it's easy is because it's really easy to find 10% of anything, and then you just double it. So for example, if my meal was $11, right? Well, 10% of $11, how do I do that? I multiply it by 1/10, or I move the decimal over one place, right? So 10% of $11 equals $1.10. And then if you doubled that, it would be times 2, $2.20. So that's pretty simple to do in your head. Like if something's $11, you're like, oh, well, 10% of $11, I just move that decimal over, is $1.10. And if I double it, it's $2.20. And so that's a really easy way of someone figuring out the tip at a restaurant. And it's a very generous way too. 20%'s a very nice tip. List 3 or more examples of real-world situations in which percents are used. Do not list any that appear on this page, such as sales tax. So we had sales tax up here. We had tipping down here. What's another way that we use percents? We also had like a percent of a population. A lot of times we use percents in surveys that we take. So like in class, I might survey all of the 4th and 5th graders. So there's like 120 of them. So I might survey all of them about, let's say, recess before lunch or lunch before recess. So I might ask them that question. Do you want recess before lunch or recess after lunch? And out of like 120, let's say like 54 say recess before lunch, right? So instead of saying, well, 54 out of 120 said recess before lunch, I can easily convert that's 0.45, to a decimal. And instead of saying, like, people like to know percents because they can kind of see, like, is that more than half, right? Or like they like to compare those percents. I don't need to know that 54 out of 120, excuse me, 120 kids said they wanted recess before lunch. Or I don't really want to say the exact number, like 45 hundredths of, or like 0.45 kids want recess before lunch, but I can convert that into a percent and say 45% of the kids would like recess before lunch. And so then I also know that then 55% want lunch before recess, right? So then I can just see really quickly that more kids want lunch before recess than don't, right? So there's one way to do it is like a survey, obviously any kind of tax, sales tax, or also when like you have a actual sale, like a percent off of something, you can use it. We've got tipping down here when we use percents. We might also use percent when we're talking about like food or recipes, or even like I've been doing a lot of cleaning this summer, and I've been using some like more natural things to clean, like vinegar and dish soap. So I might say, well, I use 50% vinegar and dish soap and 50% water in my concoction. So like when you're using any kind of recipes or liquids or measuring, you could use percents. All right, in 1990, a charity event raised $12,000. In 2010, the same event raised $36,000. What is the percent increase in the amount raised over the 20-year period? Find the amount of increase. So from this year to this year, we find the difference, right? The amount of increase. So it increased $12,000. To find the decimal value, you take the amount of increase, which is $12,000, and you divide it by the original amount. And this is kind of tricky. No, sorry, it's $14,000. Right? No. $24,000. All right, so $24,000 is the difference in the increase. So it's increased $24,000 in those 20 years. And then the original amount was $36,000. No. Amount of each increase. The original amount is this amount, right? So we divide 24,000 by 12,000 and we should get 2, right? So you convert the decimal into a percent. So 2 times 100% is 200%. So there was a 200% increase. They increased it by 200% in those 20 years. All right, Marlena deposits $250 in a savings account that earns 3% simple interest annually. So this is another thing that interest does. Not only can you be charged interest when you borrow money, but also when you put money in a bank, the bank will give you money. You can make money off your money by placing it in that bank. The bank will pay you like a small fee every year for keeping your money there. And the reason they do that is because they use your money then to lend out to other people. So like, for example, if you have $250 in your savings account and you go to the bank that day and you're like, I want to close my savings account, I'd like my $250, they'll give you your $250 cash, but that money, that like cash hasn't been sitting in like an envelope with your name on it for however many years you put that in there. All their money that's why it's called a bank. That's why we use that word bank. Like all the money that people put into the bank, it kind of all gets pooled together. And then they use that money to distribute for loans for people who then will pay interest on that loan. So that's how banks make money, but it's also a way to make money off your money that you're placing in the bank because they will give you interest. So if she makes no more deposits or withdrawals, deposit is when you put money in, withdrawal is when you take money out. How much money will be in her account at the end of 5 years? So you find the amount of interest earned. Use a simple interest formula. So interest equals principal times rate times time. So what that is here's my principal. That's the original amount I placed in or borrowed. In this case, I deposited $250. That's the original amount. The interest is 3%, written as a decimal is 0.03, and the time was 5 years times 5. So I'm going to go ahead and do that on my calculator. 250 times 0.03 times 5 equals. So the total amount that I'll have in my bank account after 5 years is $375, which is pretty good. Or that's the interest that I've earned. Oh no, sorry. $37.50 is the interest I will have earned over those 5 years. So that's the extra money that I'm getting. So I have my principal amount still in there, and I'm going to add $37.50 to it and get $287.50. So after 5 years, if I put $250 in the bank, if I were to then take that money out, I would have $37.50 more. I would have $287.50. Now, obviously, the more money you have in that account, the more interest you're going to make. So, for example, if I had $2,500 in that bank, that was my principal amount, right? And I multiply, and it's still a 3% interest rate. So 2,500 times 0.03 times 5 years equals 375, right? Let me make sure I write all that in there. 0.03 times 5 years equals 375. So this would be my principal amount. This would be the amount of interest I earned. And then you would add that together. And after 5 years, you would have a total of $2,875. So you obviously make more. The more money you have in there, the more money you will then make off of it. All right, what is simple interest? So interest equals principal times rate times time. Now it's written there, and I think you've probably seen this before. It's written with all the variables next to each other. When two variables are written next to each other, or a number is written next to a variable, that just means multiplication. We start to take that x out when we're working in algebra because x is often used as a variable. It's one of my biggest pet peeves in math. I just wish they would never, ever, ever use x as multiplication, because then in 4th and 5th grade, I have to reteach it all. Anyways, so simple interest is the principal times the rate times the time. What steps must be taken to find a percent decrease? So if you look back at the geese one, so this was a percent decrease. So you find the difference of the decrease, and then you divide the decrease by the original amount. So find the difference of the decrease, then divide the difference, or what the decrease is, by the original. And then that gets you usually a whole number or a decimal. And then you would, we're multiplying by 100 to get, then multiply by 100 to get the percent. All right, so let's take a look at 12% of 50. So basically what you do here is you turn this into a decimal, which is 0.12. Then we multiply that by 50. So 0.12 times 50 equals 6. So 12% of 50 equals 6. And then these are pretty self-explanatory. You kind of just do the same thing, turn these into a decimal, and then multiply by that number. And then you've got 3 awesome word problems that you're probably going to continue to find the percent of a number. So like this one says a salesperson earns a commission equal to 8% of the price of any piece of furniture she sells. If she sells a bed for $593, what will be the amount of her commission? So you're finding 8% of this. So when this, whatever she sells, she's getting 8% of it. So obviously if she sells something super expensive, her commission's going to go up because it's a percentage of that price. Jeff's credit card charges an annual rate of 5% simple interest. So that's another kind of place that charges interest. Credit card companies are all banks. So when you have a credit card, let's say you want to buy a new sofa, a new couch, and it's $5,000, and you charge it on your credit card. Now, if you pay that $5,000 from your bank to the credit card, the credit card usually won't then charge you money for using their company. But a lot of credit cards will charge you an annual interest just for using their services. So in this case, he gets an annual rate. That means every year of 5% simple interest. The balance on his credit card. So this is what he has left to pay. So he's going to get charged 5% of that. He makes interest-only payments for 1 year. How much interest will he have paid by the end of that year? So he's only going to pay the interest, right? So you're taking interest equals principal times rate times time. So I don't know what the interest, and I don't know why I'm writing it as an L. It's an I. So the principal is $300 times the rate is 5%, which is 0.05, and it's times 1 year. So we're basically just finding 5% of 300. So 300 times 0.5 equals, times 1 is 15. So he's paying $15. Got it? All right, and then this one is an increase by 4%. So you're going to find the difference. What is the increase of the, this is like the reverse. So when we found the increase on this one, we were finding the percent. When we found the increase on the geese, we were also finding the percent. In this case, the number of students enrolled at the school increased by 4% from last year to this year. Last year, 600 students were enrolled. What is the amount of increase to student enrollment? So you're kind of doing the reverse here. So last year, the original is 600, and this is the number you don't know, and you know it was a 4% increase. So how in the world will you find that? So you're basically finding 4% of 600 and adding it on to 600 because it was a 4% increase. So you're adding that on. So how do you do that? 600 times 0.04, find what that is, add it then on to 600. Let's say this is question mark plus question mark equals the increase. Or the, not the increase is 4%. It's equal the like new amount of students. So the new students, the new total students. Okay, and then you've got all these beautiful word problems. These are going to be tough, but if you get confused, just go back to the examples, look at what was done there, and it should help you figure this out. So these are all going to be finding the percent of a number, finding the difference or the percent of the increase and decrease, or finding the interest level or the interest of something. So good luck. If you have any questions, feel free to email me or Google chat me, and I will try and help you out. Thanks.